Hey y'all, Rusty Rob here. Welcome to another video. Today I'm going to be trying to distribute some CPU intensive work across some threads, and for that I'm going to use the Rust channels. So the easiest way to do this would be to use something like Rayon, where you just replace your iterator with the parallel iterator and it automatically splits the work across threads, and then it even does things like work stealing, so that if one thread runs out of work to do, it can take work from other threads that are quite busy, which is pretty cool. But the purpose of this is more to look at channels, how they work, and a couple of different architectures for sharing the work across threads. So let me get my video out the way. So let's just have a quick look at the code first. So right now I've just got a brute force method which checks if a number is prime. And so here it's doing a lot of checks potentially. And so I'm just going to look at the first 300,000 numbers and check if it's prime. So if I run that, we can see that runs in about just over 3 seconds. Yep, 3.8 seconds. So let's have a look at how channels work. So if we go to channels in Rust, you'll see it takes a type T, so in our case I32, and we're just going to put a whole lot of numbers into the channel, and then the workers will just take numbers from the channel, so they'll receive numbers and then they'll do their check and would like to count how many of those numbers are prime. So one thing that's interesting is if we look at a sender, it implements clone, so we can have many senders, but it says here you can only have one receiver. So if we look at receiver, it doesn't implement clone here, but we're going to find a way around that. So we're going to have each thread have its own sender. So I've got a little diagram of that, but first maybe have a bit of a think to yourself how you'd use a channel to communicate with threads. And if we look at the sender-receiver pair, which represents the channel under the hood, it might use something like a vec deck, like a queue, where you could imagine the sender pushes work to the queue and the receiver pops work from the front of the queue. And it's a bit more clever than that. For example, if a thread asks for some work to do and there's no work available, then that thread can go to sleep, and then potentially the sender, when it sends work, it can use something such as like convar, which can notify a thread to wake up and start doing some work. So that's nice. It doesn't necessarily use up resources. So let's have a look at a couple of potential architectures. So one option is to have n channels and n threads. So we create a channel here, and then we spawn a thread. So you can imagine looping through n times, and each time we create a channel and then we create a thread, and then essentially we can move the receiver into the thread, and the sender can be cloned, right? So that's one way, is to have many channels, and then when we go through all of our numbers that we want to check if they're prime or not, we can just round robin send them to different senders. And this is pretty simple. The only thing is, potentially one thread might finish early while the other thread keeps going, and we're not going to implement work stealing or anything like that. So the method I was keen to try is this other technique where you just have one channel. So we have one sender and one receiver, and then for each thread we can basically share the receiver. And I'll code this up and we'll get a bug saying that, oh, receiver doesn't implement clone, or you can't share it across threads safely. But a way around that is to wrap it in a mutex and an arc, which is like basically thread safe ref counting. So yeah, let's have a look. So first we'll import channels. So what will we need? We'll need channel. I think that's all we need. And then we'll need thread. So what we'll do is we'll have some thread handles. 10 threads. I often use with capacity because if you've got a lot of threads, they're kind of expensive to allocate, I guess. Now, I always wondered why it's called handle, you know. I guess if you're handling something, like handling a Rubik's Cube or something, it's kind of the interface to the thread, so you can join threads back to the main thread or lower the priority or whatever you need to do. So let's just assume we've finished the threads. We need to make sure we join them back. So we won't be counting like this anymore. So we will let count be the sum of all the results of the threads. So we'll go through the thread handlers. And for each of those, we're going to join them. And we'll assume that that was successful. And we'll just sum those up. And we'll sum them into an I32. And why is it complaining? Type annotation needed. Well, that'll come soon once we have a return value from our function that our threads take. And this should be an yes here. So instead of doing the prime check here, we're just going to send it into our channel. So we need to make our channel. So we just have one sender and one receiver. And so we will go sender.send I, and then I think we need to unwrap. Well, let's just see what send returns. So there can be an error sending. So we're just going to assume that it always works, so we'll just go OK. And now we need to create our workers. So for in underscore in 0.num threads thread handles.push, and here's our work. Always use move, which will move any values that we're closing over in, and we'll see that's where we get a problem moving receiver into here because it doesn't implement copy, and then we can't clone it and so on. So then we'll add the arc and the mutex. But let's just get some basic logic done first. So for now, let's just return 10 and check if this code works. Of course, we have to actually spawn something. Open the underscore here so it doesn't complain that it's not used. So let's see what happens here. So I'm expecting to get 100. Yep. Okay. Now let's just try this outside of the for loop first. call this maybe X because this, well, yeah, this is an optional I32. So first of all, we assume that this is okay, that there's no kind of communication errors between the sender and the receiver. Like if, you know, something went wrong, then this isn't going to receive anything anyway. And then the final thing is if I go like this, you know, drop sender, then we know that sender's not going to send anything anymore, which means this receiver will receive none so that it knows to stop doing work. So if let some x equals maybe x, then we can do our prime check, otherwise we can just return our count. So we need to keep track of the count. And then this needs to be in a loop. So we'll just loop forever until the sender is done, which means we need to go like this, drop sender, otherwise it will just run forever. And then, okay. Now f is prime x, count will increase. Now what's wrong here? Snake case, of course. I've been doing too much TypeScript lately. So let's try run that and see if we get any errors. And okay, seems okay. Let's just try the max prime is, I don't know, 3. So we should get 2 and 3, so the answer should be 2. Yep. So it looks good. But now if I try to do this twice, obviously we're going to get a problem. So it's complaining about this use of move value receiver. And I can't go here, I can't go .clone because it doesn't implement clone. So what are we going to do? And I'm just going to check, did I click record on this? Yep, we're recording, cool. So what are we going to do? We're going to use a for loop, but we're going to need to wrap the receiver in an arc and a mutex. So let's change our import here. To include arc and mutex. And I'm not used to this editor. That looks better. So before we do this for loop, I guess I might as well move this into the loop first. So let's wrap our receiver. So receiver, arc, mutex, receiver. And now it's complaining that there's no receive method. So what we should do is we'll go let receiver, I'll just call it receiver 2. Now what's wrong? We need to borrow that. Okay, now here's the hard part. We need to figure out how to get the data from the mutex and then receive the value. So we'll just call it R for receiver, and we'll lock this and we'll unwrap that, assuming there's no problem grabbing the data from the mutex, it hasn't been poisoned. If someone else, you know, panics while they've got it locked, then it's not good. But that can't happen in our case. And so now we'll call this R. And the problem is this doesn't go out of scope until down here, which means we're going to have the lock during this expensive piece of work and no one else can get the lock. So we need to be careful to drop R. So if I hover over R, you'll see it's a mutex guard, which is a smart pointer wrapping the receiver. And so as soon as we've got this optional I32, we want to drop it. So let's run that. And I'll just pull up my terminal here. Great. So that's running in close to a second. And we've got 10 threads. And I meant to use that variable here as well. So let's try running this with one thread. Oops. And see how long that takes. But yeah, that's pretty awesome. Close to a second. And with just one thread, it's taking, you know, over 3 seconds. So we've got a 3 times speed up. Let's try 50 threads, even though I don't have that many CPUs. See what happens. Wow, less than a second. And I don't know, just for fun, let's try 1,000. Well, I don't think it's going to get much faster than that. Now we're spending some time making threads, so it's a bit slower, but I think 10 seems like a good number to me. It would be nice to make some graphs, but I don't have time for that. But yeah, thank you so much for watching the video. So I hope you play around with some Rust channels and get some workers going. And happy Rust development.